Hi, welcome to another set of notes. Our goal with these notes is graphing linear inequalities. So with these linear inequalities, our very first step is to make sure that our inequality is in slope-intercept form. So we're solving for y. A reminder that slope-intercept form is y equals mx plus b. But remember, since we're working with inequalities, it's going to be an inequality sign, so greater than, less than, those types. So there's going to be different kind of lines and some shading involved when we're dealing with inequalities. So we're going to graph the inequality exactly as if it were an equation, except so we have greater than or less than. We're going to go ahead and use a dashed line. Okay, sometimes I call it dotted, sometimes dashed or dotted, I think, is usually what I use. Then we have greater than or equal to or less than or equal to, and this is where we are going to use a solid line. Okay. Now, the next thing that we're going to do is shading. Okay, so if it is less than or equal to, we are going to shade down or below the line. Okay, so basically we will be shading to the decreasing y values. Okay, so decreasing y values. If we have greater than or equal to, we will shade up or above the line. Okay, and so let's go ahead and get into some of our graphing. For number one, what I'm going to have you guys do is right off the bat, just write in y is less than 1/2 x minus 3. So this will be our first equation that we're going to do together. We're going to identify the slope, which is 1/2, and we're going to go ahead and identify our y-intercept, which is -3. We'll go ahead and start graphing by plotting -3 on our number line, or on our y-axis. There we go. And then we're going to remember our slope. Our slope is a positive 1/2, so that's up 1, right 2, up 1, right 2, up 1, right 2. And I know I said only 3 points, but I like to draw many so I have a nice accurate graph. And there's nothing wrong with continuing the slope movement. And so, taking a look at this inequality, I'm going to use a dashed line. So let's go ahead and do the dashed line to connect our points. Next, we have to shade for the solution. So remember that when we are working with inequalities, it is not a one-answer solution. There are many solutions. That's why it's an inequality. There's two ways to be able to do this, using the rules that I have above, but also something called a test point. So we're going to put a test point into our notes. My test point is going to be a point that's very easy to substitute into the equation. I like to choose, well, first of all, you have to make sure the point does not lie on the line, and then it's going to be easy, so 0, 0 is nice and easy. So I'm going to substitute 0 into this equation. So I have 0 is less than 1/2 times 0 minus 3. I have 0 is less than -3. If this is a true statement, then where I have 0, 0, that should be shaded. This is not a true statement, so where I have 0, 0, that should not be shaded, okay, because this does not work. Now that means I will shade on the other side of the line, not here. So we'll go ahead and shade. But then let's talk about the rules that we put in our notes up here. So I'm going to kind of just shade in a little bit darker so you guys can tell on the video. So if it is less than, or equal to, we shade down below. So this is shading below the line. It's also shading to the decreasing y values. So that's important, decreasing y values. Let's go ahead and move on to number 2. Number 2, I have 3x plus y is greater than or equal to 2. We'll go ahead and subtract, well, my goal is to solve for y, so we'll go ahead and subtract each side by 3x. When I do that, I have y is greater than or equal to negative 3x plus 2. I'm going to go ahead and identify my slope. I'm going to do this up here, actually. Negative 3 over 1, and my y-intercept, my starting point, is 2. So let's go ahead and plot this on our graph, and I'm going to box that in because I did solve for y on that one. Here's number 1. Just, nice and neat and consistent. 2 on the y-axis is my starting point. My slope is down 3, right 1. So down 1, 2, 3, right 1. Remember, we can also go in the opposite direction, where if I go up 1, 2, 3, I go left 1. Okay? Down 1, 2, 3. So I think that's probably enough. Now I see that I have an equal to sign, so with an equal to sign, I can go ahead and do a solid line when I draw my line. Next is shading. So remember that we can make a test point, okay? My test point, again, pick something easy. Make sure it's not on the line. And again, I can pick 0, 0. Remember that if when I solve it equals 0, 0, I'm going to shade on this side. If it does not equal 0, 0, I'm going to shade on that side. So I'm going to substitute 0 in. So I have 0 is greater than or equal to negative 3 times 0 plus 2. 0 is greater than or equal to negative 2. Is 0 greater than? Oh, I have a negative 2. It should be positive 2. 0 is not greater than 2. So that means that this is not a solution. I'm going to shade on this side. And the other thing is we can look back up here. When it's greater than, or equal to, we shade above. Okay, so above the line to the increasing y values. Okay, so it works. Let's go ahead and try number 3. So for number 3, I have negative 2y is greater than negative 3x plus 8. Again, we have to solve for y. So to solve for y, I'm going to divide by negative 2. I do it on one side, I have to do it on the other. Remember that same rules apply. If I'm dividing by negative to solve for y, I'm going to flip that sign. So now I have less than 3/2 x minus 4. I've solved for y. There I have it. Next, we're going to go ahead and label our slope. M is 3/2. B is negative 4, and we're going to go ahead and plot this. Negative 4 on the y-axis, this is always my starting point. My slope, I'm going to go up 1, 2, 3, and right 2. Let's do this again. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. And then in the opposite direction, down 1, 2, 3, left 2. Okay, I'm going to go ahead and do a dotted line, okay? Again, using the rules from up above, dotted line, or dashed, however you want to call it. And then from here, we have to figure out how we're going to shade. So again, we can do the test point. I like to pick that easy point that doesn't lie on the line. I'm going to go ahead and pick, I can't write test today, pick 0, 0. My test point is 0, 0. Remember, when I solve, if my inequality is true, I shade this area. If I solve and my inequality is not true, I shade opposite of that line. So that's going to be 0 is less than 3/2 times 0 minus 4. 0 is less than negative 4. Again, this one is false. And so I'm going to shade on the other side. The other thing to keep in mind is if I look, I have less than. So I'm going to shade where my y values are less than. So the decreasing y values. Okay? Number 4, we're going to do together next time I see you in class. That will be the same for number 5, but we will do number 6 together before I have you leave this video. Let's go ahead and copy down 5y is less than negative 15. We'll go ahead again, solve for y, and I have y is less than negative 3. I'm going to go ahead and write down my slope, which is a 0 slope. My starting point is negative 3. Now for this one, I'm going to go ahead and plot negative 3 on the y-axis. And I notice that it's a dotted line, so I'm going to have it go across. Through that y-axis, can you guys see that that's a dotted line right there? Hopefully you can. Didn't come out too dark. Maybe that's a little bit better. So anyway, this time we can do a test point. I would put, so my test point can be 0, 0. I put 0 in for y. 0 is less than negative 3. Well, again, that's not true. This is false. And so at 0, 0, I don't shade. I would shade below. And then, again, the other way that you would know all your y values are less than negative 3, well, that's why we're shading to the decreasing y values, because that's what the inequality says. Okay. All right, hey, that's it for these notes. Thanks, guys. I will see you next time in class. May the force be with you.